Welcome everybody. Today we will see the numerical example for k-means clustering algorithm. The example we will see is that of loan borrower segregation in a bank. Let us assume a bank manager wants to group the loan recipient into two groups for the follow-up. As k-means algorithm is an unsupervised algorithm, unlabeled data is given as input to the k-means algorithm. The inputs are the income of the borrower and the loan amount pending. Loan recipient's data is shown in the table. The loan recipient's income in thousands of rupees is in the first column. Second column shows the pending loan amount in thousands of rupees. As we need two cluster centers are randomly chosen. They are 30, 100 and 70, 200. As k-means calculates the distance, sample calculation of Euclidean distance is shown here. Let us take the first data point 50, 200 and first cluster center 30, 100 for the calculation. For example given, it is the square root of sum of square of distance of income and pending loan. The distance from the first cluster center is 101.98. Similarly, the distance from the second cluster center is calculated as 20. For all the data points, the distances from all the cluster centers are calculated as we have seen in the sample calculation. For cluster center 1, it is enlisted in column 3 and for cluster center 2, it is enlisted in the fourth column. Comparing columns 3 and 4 and finding the least value, the data point is assigned to the nearest cluster. 4 data points are assigned to the cluster 1 and 2 data points to cluster 2. The means of the data points assigned to each cluster are the new cluster centers. The 4 data points assigned to cluster 1 are shown in the table. The new cluster center is the average of the income and the pending loan of the 4 data points. The new center for cluster 1 is 32.5 and 125. The 2 data points assigned to cluster 2 are shown in table. The new cluster center is the average of the income and the pending loan of these 2 points. The new center for cluster 2 is 65 and 250. Again, for all the data points, the distances from the new cluster centers are calculated. For cluster center 1, it is enlisted in column 3 and for cluster center 2, it is enlisted in the fourth column. Comparing columns 3 and 4 and finding the least value, the data point is assigned to the nearest cluster. As there is no change in the assignment of data points, the iteration stops and convergence is reached. Data point 1 and 3 belongs to high income, high pending loan group, whereas other data points belong to low income, low pending loan group. Figure shows the graphical representation of data points and cluster centers. Cluster centers are indicated by X marks. Black dots indicate data points belonging to cluster 1, whereas grey dots indicate data points belonging to cluster 2. Though the data point 45-150 is nearer to the data point 50-200, it is clustered to low income, low pending loan group. This is due to the fact that its distance to cluster center 2 is more than that of cluster 1. Thus, k-means algorithm is used to group the customers into 2 clusters. So, in this numerical example, we have seen how k-means clustering is used for grouping loan recipients into 2 clusters. Thank you. Thank you for your patient listening.